Welcome back to Learning with us here at MPB. I'm Miss Killen. We're going to jump into some more Algebra 1 with our lesson number 9. We're solving systems of equations through elimination. The standards we're looking at today are CED 3 and REI 6. We can determine the solution of a system of equations using the elimination method. So last time we looked at substitution. This time we're looking at elimination. So let's go into, all right. So I have put up here an example when we're going to substitute in. So we're going to review our substitution real fast. When we substitute in, we get one of the variable by itself and find out what it literally means and then plug it into the second equation. So I've put an example up here. So let's work the problem using this example. So I've got two equations here to make up this system. And I want to solve for my x and y variables. It also tells me that I want to put all of my final answers in fraction form if need be. So let's go ahead and look. So using substitution, what I'm going to do is I am going to get this y by itself. So I'm going to take 4x plus 7y equals 22. And then I'm going to get the y by itself by subtracting 4x on both sides. So I have 7y equals 22 minus 4x. Then I'm going to divide my 7, all of my terms, when I end up with y equals 22 over 7 minus 4 over 7x. So now I literally know what my y value equals. So I'm going to take this literal meaning of y and plug it into my other equation to solve exactly what my x is going to be. So let's plug this in. I have 6x minus 24 equals 12y. But instead of putting the y, now we said we are going to substitute in what my y equals, which would be 22 over 7 minus 4 over 7x. Anytime that we have a number in front of our parentheses, I am always going to distribute. So grab your calculators, and we are going to distribute into our parentheses. So we have 12 times 22 over 7, and we have 12 times 4 over 7. So everybody go ahead and plug those into your calculator, and let's see what we get. So I'm plugging this in real time as you plug it in at your classroom, and we get for my first one, I get some pretty big numbers, but that's okay because we have a calculator to help. And then our next one, I get so now that I have all of my parentheses taken care of, now I'm going to start putting like terms together. So let's put our x's on our left side and our constants on our right. To do that, I'm going to add my 48 over 7x to both sides of my equation. I have 6 plus 48 over 7, and I get 90 over 7x. I'm going to add my 24 on both sides, and I would get 264 divided by 7. And then I would add my 24 to that, and I'm going to get 432 over 7. Now, still have to get that x by itself. So since I am multiplying that 90 over 7 times x, I've got to do the opposite operation and get it by itself. So then I'm going to divide by 90 over 7, on both sides of my equation. So I take that 437 over 7 and I divide it by 90 over 7. And I am going to get, for my x value, 24 over 5. Do not be afraid of these fractions. That's why we're using this calculator. Do not be afraid to go ahead and plug those calculations in using those fractions. Remember, to pull up or use a fraction in my calculator, I'm doing alpha y equals and using that number 1, numerator over denominator. So never be afraid to use those fractions. Now let's go ahead and plug in my x value to solve for my y. So let's do that. I'm going to use this right here. So 4 times 24 divided by 5 plus 7y equals 22. Let's go ahead and get those parentheses out of the way. So I'm going to have 4 times 24 divided by 5, and I get 96 over 5 plus 7y equals 22. Need to isolate that variable. So since it's a positive 96 over 5, I'm going to subtract 96 over 5 on both sides. So I'm going to take 22 minus 96 over 5, and I'm going to get 14 over 5. Still needing to isolate that variable, so I'm going to divide by 7 on both sides. So 14 over 5 divided by 7, and I get 2 over 5. So I have got my solution as 24 over 5, comma, 2 over 5, and I found that solution using my substitution method. I'm getting the literal meaning of one and plugging it in to find the exact amount of the other. So now that we've reviewed our substitution, let's look at some elimination. We're going to have some different ways that we can do this. So it says how to use elimination. Well, we've got a couple of steps that we need to review. And it says, first, I need to identify the variable I'm going to eliminate. Next, I'm going to manipulate one or both of my equations by a constant to make the coefficients opposite. I am going to add the equations together to cancel out one of my variables and then solve for the remaining variable, always plugging back into the original equations to solve for that eliminated variable. So now that we've got these steps in place, let's use these steps and see how we can put them into an example. So here we go. It says, let's use a familiar problem. A movie theater sold a total of 150 tickets on Monday. The adult tickets cost $10 each and the students' tickets cost $5 each. If the total revenue from ticket sales was $1,000, how many adult tickets and student tickets would there be? So the first thing we need to do is make those equations. So let's look. I have adult tickets and I have student tickets. All right, so I'm going to have my adult tickets be my X and my student tickets be my Y. In our passage, it told us that the adult tickets and the student tickets sold all together was 150. And then it told us about our revenue. Okay, our revenue was $1,000, and the way we got that was our adult tickets was $10 each, and our student tickets was $5 each. Now that I've got my two equations, I need to go ahead and look to see how I can use these different steps and eliminate one of my equations. Let's look and see what we've got. First, it says identify the variable you're going to eliminate. Well, I think I want to eliminate this x, and I'm putting a dot there just to keep myself organized. So the next thing I need to do, I need to make them where the coefficients are opposite. That means one is positive, one is negative, and they need to have the same coefficient. So if I am eliminating x, and I already have down here a positive 10x, I need to make up here a negative 10x. Anything I do to an equation to one term, I must do for the entire equation. So I'm going to multiply this top equation, this whole top equation, by a negative 10. So I have negative 10x minus 10y equals a negative 1500. And then I'm going to bring that other equation down, 10x plus 5y equals 1,000. And then it said for me to add them. Well, when I add a negative 10 plus a positive 10, I get 0, so they're gone. Then I have negative 10y plus 5y gives me a negative 5y, and negative 1500 plus 1,000 gives me a negative 500. Still trying to get that exact amount for y. So my y is going to equal 100. So now that I know what my y equals, I know exactly how many student tickets we sold. So I'm going to take that information, plug it up to one of my original equations, and solve for how many adult tickets I sold. So let's use this. So I'm going to bring it right here. My adult tickets plus the 100 student tickets equals 150. This is our simple calculation skills. Getting that x by itself. So I have 50 adult tickets and 100 student tickets. I have eliminated my x and solved for my y. Then when I got my y information, I plugged it back into my original equation and solved for what my x was. Okay, so that's how we're eliminating. When we're eliminating something, we're getting rid of it. Like if a job is eliminated, that job's no longer there. Or if we have eliminated a problem, that problem is no longer there. So that's what we're talking about when we say elimination. We always want to make sure that we're getting rid of something to solve for something else. So look at some more problems. It says, you make a number equation and a money equation. So we've learned number plus number equals number, money plus money equals money. So let's take that information and look at Sarah's problem. Sarah's shop sells 2 types of cold coffee mixture, mocha and vanilla ice. A pound of mixture of mocha costs $10 and a pound of vanilla ice costs $12. If Royal buys a total of 5 pounds of mixtures and spends $56, how many pounds of each mixture of the mixtures will Royal buy? So let's go ahead and make our 2 equations and see what we've got. First of all, I know that I've got mocha plus vanilla, and it says that he wants to buy a total of 5 pounds. So there's my first one. Now, number plus number equals number. Now let's go to the money. I'm still using that mocha and I'm still using the vanilla, but now I've got to put my money with it. It says that mocha costs $10 a pound, and it says that vanilla ice costs $12 a pound, and they're going to spend $56. So we are going to use elimination to solve for this. Remember, in elimination, I'm getting rid of one thing so I can solve for the exact amount of another thing. So let's go ahead and look at this. Let's eliminate our vanilla. So that means I need to have them opposite with the same coefficient, one positive, one negative. Since I have a positive 12 down here, I'm going to multiply everything on top by a negative 12. So let's see, negative 12m minus 12v equals negative 60. Then I'm going to bring my bottom equation down, and I am adding everything in this equation. So negative 12 plus 10 would give me a negative 2. Negative 12 plus 12 cancels. And then a negative 60 plus 56 gives me a -4. Still needing to get that m isolated and by itself, so I divide by -2 on both sides. So my mocha costs me $2 per pound. So I'm going to go ahead over here and put 2 as my mocha. Now I need to take that information about mocha and help me solve for my vanilla ice amount. So let's plug that in. So I'm going to go right here and put in 2 for my mocha plus my vanilla ice equals 5. I'm subtracting just like we've always done, and my vanilla ice cost me $3 per pound. I took information that I didn't have and put my variables m and v, made 2 different equations, eliminated my v to solve for literally what my m was, which was 2, and then plugged that back in to solve for what my vanilla is. That's all it is to our elimination, taking one thing, getting rid of it, and solving for another. So let's look at another one. Okay, so we're going to do some practice. We're going to take what we've learned and plug it into some new problems. So let's look. The only coins Linus has are dimes and pennies. His coins has a total of $6. He has a total of 123 coins. How many dimes and pennies does he have? Okay, so from our problem, we are going to build 2 equations and then use elimination. So let's see what information we have about this. The coins we have are dimes and pennies. It told me that I have a total count, meaning I'm adding, of 123. So I've done number plus number equals number. Now I'm going to do money plus money equals money. So how much does a dime cost? A dime is 10 cents. That's right. How much does a penny cost? It's a penny. It's 1 cent. So how can we put that into our equation? We're going to have to use decimals. So for my dimes, I'm going to put 0.10, and for my pennies, I'm going to put 0.01. So let's look and see what we've got. So I've got 10 cents for the amount of dimes I have, plus 1 cent for the amount of pennies I have, and when I get all of those together, I have $6. All right, so what I need to do now is to think, which one of these do I want to eliminate? Well, I am going to eliminate my dimes. So I have 0.10, a positive on the bottom, so that means I need to have an opposite on top. So I need to have a negative 0.10. So I'm going to multiply everything on top by a negative 0.10. So here we go. So I have negative 0.10 dimes plus, nope, not plus, because when I add a negative, it's just like subtraction. So I'm going to have minus 0.10p equals. Now, we're going to have to multiply this. We're going to have negative 0.10 times 123. And what do I get? I get a negative 12.3. Then I'm going to plug my other equation under the bottom, just the way it is, because we have not changed it. And like we said, we're going to add. So negative 10 plus a positive 10, they're gone. Then I have a negative 0.10 plus 0.01, and I get negative 0.09. And then I have a negative 12.3 plus 6, and I get negative 6.3. I need to make sure that I am isolating that p variable. So since I'm being multiplied, I'm going to divide. We have learned negative divided by negative is a positive. So when I divide, I get 70. I have 70 pennies in this scenario. So I'm going to take that information about my pennies and see if I can figure out how many dimes I have. Let's plug it in. So I've got, let's get another color. So I've got my dimes plus 70 pennies equals 123. I subtract my 70, and the total amount of dimes that I have is 123 minus 70, and that gives me 53. So I have 53 dimes, comma, 70 pennies. We could always plug that back into our second equation to make sure that the money adds up. So there's multiple ways that we can check our work to see if we've done the correct math, make sure that we've used the correct decimals. You always want to make sure that you're checking your work. Let's try some more. It says it's time for you to master now. So I'm going to read you the problem and see what we've got. Charlie and Lucy bought identical priced bottles of energy drinks and identical priced bags of hot chips. Charlie bought 3 bottles and 2 bags for a total grocery bill of $10.07. Lucy bought 2 bottles and 4 bags for a total of $12.98. Write and solve a system of equations using elimination to solve for how much each bottle of drink and bags of chips cost. Go ahead and pause the video. You work independently or with your table partner, and then come back to me and let's see what we got. Okay, so let's see what you got. Let's see what I got. What I have for Charlie, let's make it a little brighter. So what I have for Charlie is 3 times my bottle plus 2 times my chips is $10.07. What I have for Lucy is 2 times my amount of bottle plus 4 times my amount of chips equals $12.98. Now, like I said, I need to make sure I am seeing which one I want to eliminate. I am going to eliminate my bottle, and I'm going to use my Lucy problem to do it. I'm going to keep my Charlie problem, or my Charlie equation. But what I need to do now is take my Lucy problem and figure out what B is. So since I have a positive 3, I need to get a negative 3 down here on the bottom. Well, what would I need to do to Lucy's 2B to equal 3? Well, let's see. If I take that 3 and I divide it by 2, I get 1.5. Since I wanted a negative, I'm going to multiply everything in Lucy's equation by a negative 1.5. So I'm going to get 4 times a negative 1.5. So I'm going to get negative 6c. Then I'm going to take negative 1.5 and multiply it by 12.98 and get a negative 1947. I'm going to add these. Positive 3 plus a negative 3 cancel. Then I have 2 plus a negative 6 gives me a negative 4c. 10.07 plus a negative 19.47, I get negative 9.4. I want to make sure that I am isolating that variable, which is c, so I'm going to divide on both sides by a negative 4. So my amount of chips is going to be $2.35. So let's put that over here. So my chips equals $2.35. So now that I have found how much my chips are, let me plug that back in to see if I can find out for my bottles. Now I'm going to have to erase my work so I can have room. So make sure that everybody's work looks something similar. And then I'm going to erase. All right, so now that I have this erased, I'm going to use Lucy again and put 2b plus 4, what the amount of my chips cost, which is $2.35, equals 12.98. Always want to make sure that I get rid of those parentheses, so I'm going to say in my calculator 4 times 2.35, and I get $9.40. And then I'm going to bring everything else down. Isolate my variable by subtracting 940 on both sides. So 12.98 minus 940 gives me $3.58. I'm going to divide by 2. And my bottle of energy drinks equals $1.79. So if I wrote that up here, let's see, B comes first, so I'm going to put 1.79 comma 2.35. So that is how I got my bottle amount and my chip amount. Let's not forget, make sure you have an equation for everything that's in your problem. Make sure that you're accounting for numbers and money if there is money involved. Most of the time you will have a numbers portion and sometimes you will have a money portion, but you always want to make sure that you're reading through those problems, making sure everything's accounted for. You want to make sure about your elimination. We are identifying the variable that we're eliminating. We're multiplying one or both of the equations by a constant to make coefficients that are opposite. We want to add the equations together to cancel out one variable. We're solving for that remaining variable, and then we're plugging it back in to make sure that we can solve for that other one. We want to know that when we found one, we can use that to find the other variable. Thank you for coming to learn here with us here at MPB. My name is Ms. Killen, and I've had a great time with you. Thank you.